Hello everyone. Yeah, Steven here again from Kampala DevOps Community. Once again, welcome again to yet another session led by Promise. Promise, we're glad to have you again. Yeah, this is your second session. You took us through DevOps fundamentals initially, which was a really insightful session. For those who haven't seen that recording, the recording is on our YouTube channel. But yeah, Promise really took us deep, and yeah, she's back to share more knowledge and insights with us. But this time around, focused on GitOps. So without further ado, I would request Promise to take over. Welcome, Promise. Nice to have you again.
Nice to have you here. Nice to be here again, and nice to see. I'm not seeing anybody, but nice to see everybody again. I think for those that just see me for the first time, I am Promise from Nigeria. I am a site reliability engineer. I've been in the field, I think, for 4 years already, and my main responsibility is just building infrastructures and trying to make sure that the systems that the applications or softwares might be running on are as reliable and available and scalable as possible. Yeah, so today we would be looking at the whole concept of GitOps itself. So we have the old DevOps, GitOps, different names for other stuff. But when we talk about GitOps, it's just, Git and operations together. How does it fit into, the same container? So you've heard of DevOps too, how DevOps comes together with, devs and operations. GitOps comes together with Git and operations. So basically it's a culture. Just like I would say, DevOps is not a role, but a culture. It's something that you practice in your organization or when you try to build an application or when you try to send an application to an end user. I'm trying to use a non-technical term as much as possible. So yeah, I would try to keep it as short as possible because I believe the longer something is, the less interested people are. Especially for me, if it's too long, I lose interest. So yeah. So I try to keep it a little bit short and so you can have time to ask your questions and we can just discuss. I would also like to hear everyone's view on the landscape itself when it comes to GitOps. So I am also open to listening, Yeah, so before we jump in, I would want you to take a second and just think about like the last time you were building something locally, or if you're already working, you were building something in production or in your dev environment or in your staging, and then I do not I do not mean when you have a bug in your code or whatever. That is not what I mean. Let's say you change something in your infrastructure and you change something in your infrastructure and something broke, right? So think about that time. Maybe at that point you did not know what changed, who changed it, or when it was changed and all that. It happens often in teams where I think probably they are so large. Teams work like in a very silo system, so it is really difficult to know who changes what, who did not change what, and so on. It might be that somebody just went locally and ran some quick quickly fix something and just ran some quick kubectl command just to fix it. And then probably the person the person did not tell anybody, or if it's just you in your local environment, you forgot, and then something breaks, and then you do not know what breaks, right? Another thing you can think about, another example can be, you have a CI pipeline a continuous integration pipeline, right? And you push something which you should not have, right? It might be in your staging environment or your production, whichever one. And then it started behaving, completely different from what you had in mind. So let's say you push something to staging, and then it started behaving differently to what you have in prod, or you push something to prod and it started behaving differently from what you actually had in mind, like the end result of what you were looking for, right? Now, if all these things I just mentioned sounds familiar to you, it happens in most engineering, team. Most times people push something that breaks something, and then you have to start thinking, okay, when was this change? When was the last time? Who did the deployment and so on? It happens often. That's why every engineering team usually operates what we call the blameless culture, right? You do not blame somebody, just one person for what happens, because these things could happen. Based on all the things that we talk about, can you go to the next slide? So based on all the things that we just mentioned so far, I would like to show you what you would learn today, right? Like I said, it's more of a discussion, and we just try to understand what is going on in this whole landscape of GitHubs, why more teams are, gradually more pushing into, the whole GitHub's culture and all that. So the first thing we'll talk about is the blueprint of reliability. I am a such reliability engineer, and GitHubs also plays a huge part in our reliability culture. And when you think about the blueprint of reliability, you want to think about, okay, we always should use Git as our single source of truth, right, for your entire stack. There should be like this big project. If you're using GitLab, we call it project. So there should be like this big project where everything, all the stack lies. So that's single source of truth. Now we also will talk about the push and the pull models, and why I favor the pull-based model more than the push model. And then we'll look at the drift detection, and we'll talk about drift detection. We're saying, okay, since we now use GitHubs, what is the what's it called? What is the how do you recognize, like, okay, your environment is a drip, somebody makes a manual change, a node restarts and so on, and then you now have this fix of where your Git operator, your GitHub's operator that you have in your environment just fixes it. Because if you have a GitHub's operator running in your cluster, it is able to sync your desired stage with your actual stage, right? Your desired stage is what is in Git. So that is your single source of truth. Your actual stage is what you have in your cluster. I will give you an example. Let's say I go to my Kubernetes cluster and I delete a pod. So let's say I have 3 replicas and I delete one. And I have 2 replicas. But my single source of truth says I should always have 3 replicas. So what will happen? It would look at the desired stage and then just, sync again. So it is able to, we'll talk about this drift detection and why it is so important to reliability. And then the last thing we'll look at is, okay, what are the best practices for you to, scale, right? You have multiple environments, and there's this manual overhead of people trying to, scale multiple environments. But with GitOps, it plays a huge role here in terms of the best practices for you to actually scale your environment. So let's really look at the first thing. Your Git as the single source of truth, right? So the foundation of everything in GitHubs is this idea, right? Git is your single source of truth. not your Cloud Console, not your kubectf on command, not your what's it called? Not your, which other one do we have? Not your Git, your local environment, right? Git is your single source of truth. What's it called? We also have confidence, right? Confidence is also not your single source of truth. It should be Git. It is not your senior engineer who's been there for years, let's say 10 years. It cannot be your engineer. Because if you're looking for something, you should go, there should be like a single source of truth for it. So you would go to the, what's it called? To that single source of truth. And your senior engineer should not be that. Your confidence should not be that, right? Everything, all the knowledge should be in the Git, right? And for me, this means really something specific for me, especially. Look at it this way. Every piece of your infrastructure, whether your Kubernetes manifest, whether your Nchart, your Terraform configs, your role-based access control rules, your network policies, and all that, they should all live in a repository, right? They should be in a repository written as a code. It is not something you would go manually and create. It should not be done. Nothing should be done manually when it comes to the GitOps practice. Nothing should be done manually. Everything should be written as code. And it is what we call a declarative format, right? You've heard of the imperative, you've heard of the declarative. I am assuming that I am talking to people that need to be technical, whether you're a beginner, whether you're mid-level, doesn't matter. You should have heard of the declarative and the imperative format, right? Now,
Yeah.
so everything should be in a written code. That is the first rule of GitOps, right? In a declarative format, which means you are not writing scripts that says, go and do this and then do that. No, you are writing files that would say, okay, this is the states this should be in. And then your GitOps tool, let's say your GitOps operator, will now say, okay, you have said that this is the state you would like, which is present in your Git, right? Now, what will I do? As a tool, I will then make it match, right? So that is the GitOps concept in itself. You design, you declare, that's why it's called the declarative format. You declare and say, okay, this is the state of the infrastructure I want. Now, your job as a GitOps operator would be to always make it match. Yeah, so we are looking at three, before I go here, I just remember to talk about something. We are looking at three things here, right? Just to be sure that we understand. We're looking at three, just look at it as like a three bots that we're looking at. One, we have the declarative config, right? When you look at the declarative config, which I just mentioned, this is what shifts your mindset from imperative to declarative, right? Then you're looking at, okay, I have to write everything down in code. You stop thinking about steps and start thinking about, your desired outcome. That is the first step. You move away from, okay, what are the steps that I need to take? You move away from that. Then you start thinking about what is actually the desired state that I want, right? This small shift in the mindset that you have, it's a very huge, big, practical, it's a very huge practice in the concept of DevOps, SREs, cloud engineers, and all that, right? Another thing you would think about in that box is like, your audit, right? This one is very, very important when it comes to your day-to-day work in this whole GitHub. Every day we do with GitHub. So every change, you have to see every change as something you are committing to, right? So you have your Git commits that have authors. So if I am Promise and I do a Git push, I am the author of that commit, right? There are timestamps, which means it would put like a time that I actually made that commit. And then I will have to give a commit message. So you can see this is where we have the auditing and the trace, right? It will track everything. Now, when something happens, right, you can then, first, I'll give you like a practical work example. A few days ago, a CI pipeline was breaking. And what did I do? I just went to the history and I tried to look at, okay, who made the last change that broke the pipeline? And then I was able to trace, trade, do the auditing to see what changed, why before this happens, why now is it breaking. So I was able to trace it to, the author, and then wrote the author to say, okay, your last change broke the pipeline. Could you please revert your changes? Now, because he's the author of the commit, he's able to revert the changes and the pipe to to the pre-commit stage where the pipeline was actually working. So this is where the auditing actually comes in for Git, right? This really matters, like I mentioned, this really matters for incidents, because then you are able to see, okay, who changed what and why, right? Now, it doesn't mean that you're going to blame the person for changing anything. That is why you practice the concept of a blameless culture, because the first rule should be, it is not about who changes anything. It is about how do we fix it? What is the quickest way to fix it before we start finding out why did the fix break something, right? Now, the third thing in that box that comes to mind is, okay, rolling back, right? So you have your declarative config, then you have, okay, the concept of you being able to make trees, audits, this all commits, right? Of what changes and what does not change. And then you know how to, okay, the roll it back in seconds, right? Because that is the main thing. If we're going to make any changes generally, the first question we usually ask ourselves as a team is, how fast can we roll back if something breaks? So for instance, I did a database upgrade a few days ago. And the first question that the senior engineer asked was, okay, if something is breaking, how fast can we roll back to the previous version, right? So rolling back, there's a bad deployment. You cannot manually do it, or like you cannot manually go and undo a bad deployment. You probably do not know what the previous config looked like, right? What do you do? You would then run a git revert, and your operator would, automatically restore it to the previous stage, right? So you can see that we still go back now to matching desired stage to actual stage. Now, because of this Git operator or this GitOps culture, rolling back becomes very easy. It will just be like, okay, let's just revert the changes, right? You do your Git revert and it reverts to the branch where it was actually working. Sorry, the commit, the last commit that it was actually working at that time. Now let's look at the architecture itself. How does the architecture look? It's like this: a developer, a DevOps engineer, whoever would make like a commit, right? So the it is where it all starts, right? The SOE, the DevOps, the developers, whichever one, they would make like a code change, or you as a DevOps engineer, you would edit your manifest, your values, and so on, right? Then when you edit, you comment, then you push, right? And this push will trigger a pull request. ideally, that should be it. You definitely would not want to push to the main branch, even if it's a little change that you're gonna make. According to the GitOps practice, you should always do every change in a new branch, because when you do it in a new branch, it will then trigger, when you push, it will then trigger like a pull request, right? Now, in this case, your PRO with your pull request or merge request, I never knew the difference. I'm still trying to figure out the difference between merge request and pull request. So bear with me if I interchange the words. So because most times I call it merge request, sometimes I call it pull request, but never mind. So I'm talking about the same thing in case you catch me saying it differently. So your pull request will go through, reviews. That is very important also. You should never merge anything without without a review. So most companies would have this thing called code owners, right? That you can add to the reviews, and if they do not give approval, you cannot merge, right? It blocks the merge button. So this will go through, reviews, policy checks, and so on, right? Nothing would get merged until somebody approves. So you are able to keep an eye on it, right? Now, what will be the second lane? So now we can see we have 3 lanes, right? The first lane is the developer lane. Here, every commit, everything, you create your pull request and so on. Now we go to the second lane where we would have the Git and the CI. So your Git and your continuous integration. So once the PRL merges, right? Obviously you're in the Git repository, the PRL gets merged. Now you have your single source of truth, which has the new desired state. Now keep it in mind, your desired stage, your actual stage. Your actual stage still remains right now, because you've merged to your main branch, because especially if you're working with Argo CD, you have to now create like application sets or applications where you put your repo URL and you put the branch that it should constantly sync against, right? So as long as you've not merged to that branch that you say, okay, my operator should constantly watch this branch. If anything changes, that will be the desired stage, because that is the truth. That is where we want our desired stage to be. And whatever is running in the cluster, it is the actual stage, right? But because the desired state has changed, what does the operator do? It constantly watches that branch. And if you make any changes, which you just did, you did a PRO, you mentioned something, it will then say, okay, this is our new desire stage. Your CI pipeline will kick off, which is maybe you have your YAML links, you have your whatever you have there, right? You have your tests, you have your builds, you have your container image. It pushes your image to, a container registry with a tag and so on, depending on how you build your CI pipeline, right? Your CI pipeline's job is not to deploy. It should never be to deploy. I have worked with companies that we had to do the push. So we had to do deploy through the pipeline, right? But it should never be. Your CI pipeline, the job is to just build and publish. That should be the job. It should not deploy anything to a cluster. It should not do that. Deployment should be something separate. Someone else's job, which it would be probably your operator or whatever, but you should not do it in your CI pipeline. Now, we've talked about the developer lane. Now we've talked about the Git, which is your single source of truth, and then your CI, which you will do your whole testing building and so on. Now the last thing will be your cluster, right? Now, when you look at the last thing, which is your cluster, you're going to look at, okay, there's a GitOps operator, which might be Argo CD, Flux CD, depending on which one you choose. I am a huge favor of Argo CD because I can see the UI, but I've also worked with Flux CD. They do the same thing. It's just that Argo CD has a UI which is very pretty, and it's much easier to just go to the UI and see what is there instead of doing everything in the CLI.
Quick one.
Instead of trying to see everything on your local environment, when you connect to your cluster, you could just go to your Argo CD UI and so on. But
Promise.
circling back,
Flux seems to have a UI powered by Weave, right?
yeah, but that's
Yeah, okay,
an
I
extra
understand.
step that
Understand.
most teams do not just implement, because you have the weave where you have your customer. It just shows you like if something is ready or not, right? So if you have the flux with the wave, you would see, okay, this pod ready or not ready or whatever. It doesn't really give you like a granular view like Argo CD would. I would do a little bit of demo on what the Argo CD UI looks like, and then probably everyone can make their judgment on whichever one they like. But I do
Sure.
favor Argo CD more.
Yeah.
So circling back, you have your operators, right? And it can be Argo CD, it can be Flux CD, whichever one you deploy. They do the same thing. There's no difference. They are all, let's say this operator is running inside your cluster. Now, what does this operator do for you? It will continuously watch the Git repository. Remember, for if you work with Argo CD, you will have your declarative config where you can either, I think the kind can either be application or application safe, whichever one you want. But there are differences between them, obviously. In this config, you would see like a line called sorry, a GitHub, your repo URL, right? So it will constantly watch that repo URL with the main branch. Sorry, whether it's the main branch or that whatever branch you declared it, but you constantly watch that branch. Now, it depends on how many minutes or seconds you want it to wait until it pulls your desired state. Most teams put it for 5 minutes. Most teams put it for seconds. So it will constantly, at that particular time, when you make the change, it can wait for 5 minutes to say, okay, that was a change in this last 5 minutes. Let's check it out. Or there was no, but it would check every 5 minutes to say, okay, did anything change? I'm just saying 5 minutes just to have like, an estimate. You could make it anytime. So it will check every 5 minutes to say, okay, did something change? Did something not change? And so on. Now, when it sees a new commit, remember this is an operator that is inside your cluster. So when it sees a new commit, it then will pull that your changes, whether it's a manifest, whether it's your M values that has changed and so on. It will then pull it. And then this is where my favorite thing comes in. Now, upper is your gatekeeper policy, right? I usually like to integrate it into my GitOps concept, because they need to be something that checks and balances what has been changed. Now, the upper gateway policy will then validate your, whatever rules that you've put in your, policy files. You can say, okay, whatever is deployed, I do not want this to be, I do not want my resource. So whoever tries to make a deployment, I want that the resource parameter, the request should match the limit, right? For those of you that are working with Kubernetes, you might understand what I'm trying to say. You can say, okay, you can define in your policy to say, okay, I want my the request to be the same as the limit. Now, if it's not the same, you should block it. So the validation phase, right? Now, if everything passes, let's assume everything passes, your gateway policies checks and everything is fine. Another thing you can use here, I think, is Kibano or something. Yeah, there's Kibano too. There's Opera too. I currently use Kibano at work, but I use Opera in my local environment. So if all these changes passes, it will then apply the change. So if all this validation goes, check, it will then apply these changes, right? The cluster, your cluster then will now end up with your new desired state. And there's no, at this point, there will no longer be drift, because before there was a drift between your desired stage and your actual stage, actual state. So now when everything is, together, it's, there's no longer drift, right? Nothing, everything is reconciled. In Agro City, they call it syncing. Now, notice how these lanes are. If you check, there's the push, and then there's the pull, right? Now, what is the push? The developer or your SRE or your DevOps, they push something to Git. It triggers a CI pipeline. Now, what does the operator do? It then pulls what is in Git. So you can see from this image, there's the pull arrow back. Now there's the push to this place. Now there's the pull here. It pulls from this Git and the CI. This now is where we build upon our pull versus push models, right? Now, why does the pull model go, have much more advantage generally? When you look at the push model itself, this is how most CI pipelines were built before we had this whole concept of GitOps, right? Your GitHub Actions workflow or your GitLab CI, whichever one you're using. I use GitLab CI, so I will mostly base my examples around GitLab. Now your GitLab CI, or your Jenkins, whichever one you're using, it runs, right? It will then build your artifact. This is now the, it will then build your artifact, and then it will push your deployment directly to your cluster. That is the push mode here, right? Your CI/CD pipeline pushes directly to the cluster. You do not have, now, in order to do this, you need credentials, obviously. And this needs to be authenticated with your Kubernetes API server. Or, yeah, it will always be Kubernetes. So I am using Kubernetes in this example. This you have, so I repeat, you will have your CI/CD pipeline, right? You push to this place. It runs your build. Now, in order for this to work, it also needs to authenticate with your Kubernetes, API server, which means those your credentials would live inside your CI system, because you are not using, now we're using the push model, because you're building this pipeline and directly deploying it to your Kubernetes cluster. So which means your credentials would live inside your CI system or your CI pipeline. Now, this is in the concept of security, this is very wrong, right? If someone gets access to your pipeline, they have access to your cluster. As simple as that, because they have the credentials there. If those secrets get leaked, let's say in logs and all those stuff, there's already a problem. Your cluster is already compromised, right? Now, this does not look right. That is why a lot of teams now moved to the pull model. I mean, people still do the push model, but a lot of people now are now using, the push model. So in the pull model. Now, why does the pull model work better? Now, with the pull model, instead of your pipeline to push into the cluster, what do? You would deploy an operator inside your cluster, right? So it might be Argo CD, might be Flux CD. Now, what is the job of this operator itself? Entirely, its job is to just watch your Git repository and then pull the changes when it sees it. That is what it does. That's what the operator does. Your cluster reaches out to Git and say, okay, I will be the one reaching out, but you cannot reach in. What does that mean? You push something to your Git repository. I, as the operator, I will go and check. But you cannot come and check me because you do not have the credentials. But I, as an operator living inside the cluster, have the access to check yours. Because everything lives in the cluster, no credentials is exposed to the entire public, or accidentally would get exposed. So reaching out, but Git cannot reach in. So this would mean that your CI pipeline will never store credentials. There's no way you're going to put a certificate on your CI pipeline, your Kubernetes token or CI pipeline to say, okay, this is my API token to authenticate to my Kubernetes cluster, do this and so on. That will never happen, right? Now, the operator will continuously run inside the CI pipeline, right? Continuously run, continuously watch. Now, what happens if your CI pipe system is completely down? The operator keeps reconciling because it only watches your Git repository, not your CI pipeline. Even if your CI pipeline is down, it will continuously just watch your Git repository because it is not based on your pipeline, right? Now, pull-based model is not a recommendation, actually. It is what should be done. It should be the default model, generally, right? Now, we've talked about, the push, the pull model, right? Now, let's look at how the concept of this whole syncing, reconciliation, and so on. Now, this is really one of my, favorite things to talk to, that when I work, and it fascinates me, actually. The syncing, Argo CD with my GitHub repository and so on. Let's look at, okay, if there's a drift, what happens? But first, what is a drift itself, generally? When you look at drift, it is when your life environment, right, stops matching your desired state. So what is your life environment? It is what is in your cluster. The deployments you have in your cluster, it is what is life. It is there. Your desired state. What's your desired state? It is what is in your Git repository. And this happens all the time, obviously. This might be that someone decided to go and edit the deployment manually just to quickly fix something, right? And then, let's say the node restarts, something, does not work, and so on. There's a drift. This is where your operator will now come in and say, okay, there's a drift somewhere. I need to fix it. In your traditional push model, it doesn't pick it up because your traditional model is just to push. So you push to the cluster. It does not detect a drift out of nowhere. Your pull model will then, it is what would detect a drift, right? Now, GitOps is what solves this reconciliation problem, right? Your desired state would be, if you check the image, your desired state would be in Git, right? Your operator observes the cluster. So operator observes the cluster, and then the moment it detects that the live stage doesn't match what is on Git, that is a drift for that operator. Then it will immediately trigger a reconciliation. Now, remember, depending on how many seconds you have or how many minutes you have set the watching, like I call it, you could say check every 5 minutes, check every 2 minutes, and so on. So that is what it is generally about, right? Operator would sync every 24/7 and so on. Now, here are the practices that I recommend or that I try to implement in my own environment or even at work. There should be an environment branching when you are doing GitOps. There should be an environment branching. You need a clear strategy for each stage, whether it's test, whether it's stage, whether it's prod. There should be a different branch for everything, right? It could be a monorepo with different directories. It could be you have different repos for different stage. For instance, we operate in the concept here, we have a monorepo for everything, but just different branches, right? Now, the second thing that's very important here is your secrets management. I think it came on a few weeks ago, and they were talking about retiring the concept of Argo CD encrypting your secrets. Now everybody has to move to, using a secret operator and so on, which should be the actual thing to do. But most of the times, we want something really fast. We just use Argo CD to encrypt the secrets and so on. Git should not be your secret store, first of all. Your API keys, your password, and so on should either be done by, there's seed secrets, there's HashiCorp Vault, there's the external secret operator. Which one do I recommend? Is the external secret operator. That is really way better. This things or this tools I just mentioned is what will help you store your encrypted secrets, and then you reference it in your Git and so on, right? The third thing is the policy as code, right? When you look at the policy as code, you realize that you cannot rely on developers, especially, I'm an SOA, so I cannot rely on developers to always remember the rules. There are developers that will want to run container as root because it makes their work easier. They don't have to create users or groups or so on. You cannot rely on those people to remember the rules. Now, this is where your gatekeepers comes in, whether it's Kivano, whether it's Opera, and so on. You can say, okay, all containers must have resource limits, or all deployments must have resource limits. All containers cannot run as root. You set all those things, and then you enforce this automatically when that workload is being deployed. When the config that is not compliant is deployed, they do not get deployed because it is valid. There's this admission validation hook that you have that is blocking it. This is how you do actual GitOps. You have your Git, you have your operator, and you have your policy checker, your validation checker, as I would say, call it. Right? Now, the last thing here is your observability. You should tag everything. Tag all resources, tag everything. Every Kubernetes resource should carry a metadata, right? If it breaks in production, you are able to trace it, to your metrics and say, okay, this is this is what is breaking. This is what we changed that is breaking, right? You are able to, trace it with your observability tool. You are able to say, okay, the commits to what caused the problem and so on. GitOps gives you this audit tree, obviously, but observability is what gives you the visibility to use it, because there's the other tray too, in your GitHub. But when you tag all your resources with the commercial, you correlate it with your metrics and logs to the exact Git change. Because if you are saying, okay, let me go to Git and start searching for who made this exact change that, made it break, that might be taking a lot of time. And especially in production, every second matter because you have to bring the service back on, right? Before we come here, I would like to show you an example of what a GitOps concept, a GitOps workflow would usually look like. I do have Rancher running in my local environment. A lot of people would use KTVS and so on, but I like Rancher because it's a text Kubernetes thing and I can just see everything I am doing. So, I think it's still running, obviously, but I would show my, this is my local environment, right? And I do have Argo CV and everything deployed. If you would like to see the scripts to do this, it's on my GitLab URL. I think it will be sent to you along with the materials and so on. So everything is running. I just have to port forward with my Ranger to show you like what an actual UI looks like. So I can port forward here, I think so. And to port forward, I just have to check the Argo CD, look for the Argo CD server. And because I'm using HTTP, I just maybe port forward to be safe. I don't know which port I'm currently using in my cluster, but I just stick to this. So if I port forward here, if I come here, I can do my localhost. I have the UI and I have to look for the password. So this is what a typical Argo CD UI looks like, right? And I already did some configuration somewhere. You can check the maybe my GitLab. I can just copy the URL to you. Is it GitLab or GitHub? Which one did I use? I don't remember, but I will send it later with the code, with everything. So I have a script that just bootstraps the Argo CD on my cluster, the gateway policy, the gatekeeper policies and all that. Now, why am I showing you this now? You can see that there's one warning here, right? Now, the one warning here was me trying to deploy something that the upper was blocking. You can see the warning is telling me that the namespace is production is part of applications, sample API, whatever. Now, why is it saying this? Because I am deploying two resources in one namespace, which I have in my validation policies to say each service should have their own, namespace. So which is why it constantly shows me like a warning. Now, this is a warning because I put the policy to say, okay, just make it a warning. Do not block the deployment, right? Now so I just deployed the simple API, and here you can see another thing in here. You can see it still shows the same warning because they are running on the same namespace. So that's what I wanted to show. If you would like to, try this out by yourself, like I said, there's a GitHub there's a GitLab project that I have that you can just copy. It bootstraps your Kubernetes cluster and so on, and just deploys everything, and then you can, check. But I just wanted to show you what an example operator would look like. Now, this Argo CD runs as an operator inside the cluster that constantly will check my Kubernetes cluster and then check my Git at the same time. To just wrap this up, wrap everything up. Remember, GitHub is not just like, okay, just for your code. You should treat it as, your single source of truth. It should be where everything lies. Something should not be local, and then it doesn't match what is, inside, right? Now, what should be the next thing? Because the moment you start treating Git as your, I could usually say control plane for your entire infrastructure, you then do not just see it as, okay, an application code. You would see it as, your infrastructure itself, because then that is where it would become, reviewable. You can audit it, you can reverse, you can collaborate, and so on. The pull a pull request for a config, the changes will then just carry exactly the same weight as your pull request or a feature, and so on. When you practice this, it changes everything, because then you are able to, bring everything together, your Gits and your operations. So GitOps together. And keeping in mind, like we said, that your continuous reconciliation is your safety net. When a drift happens, humans make mistakes, systems will misbehave, and so on. When you have automated reconciliation in place, your infrastructure will always, restore to order. You stop relying on individuals to go and check what's happening and so on, because you trust your single source of truth, except you've done something bad there. That's when you do not trust it. But if you trust your single source of truth, you would rely on it to constantly, sync with your desired state, right? And then keeping in mind that GitHub only scales only if you set it up right. Argo CD would only work if you set it up right. Your flux will only, because there are so many best practices in setting up others, others tools. It's not just about, setting it up. You have to implement, security checks. You have to implement, my config being set in order. You have to decide which should I use. Is the application set? You have to make these engineering decisions, right? Use branching strategies, secrets management, policy as code, implement observability. This is what makes it scale. This is what makes it work. So I hope this, this whole talk for the past 1 hour or so has been helpful, and it has actually shown you why GitOps is very important in every, environment, in everything. Because it's not just about, like all these people I do mentorship for, it is not just about using the tools. It is understanding the principles behind the tools. That is what matters. Because there are so many tools for this. There's Fluxity, there's Argo CD, there's so on and so forth. What matters is, do you understand the principles behind it? Do you understand the best practices to implementing this culture, whether it's DevOps, whether it's GitOps, whichever one? It is understanding the culture behind it, right? So, because when you understand the culture, the practices behind it, the reason it makes sense to you, and the implementation becomes much more clear, right? Yeah.
At this point, I would say really thanks for those insights around GitOps, because as you know, I think most CI/CD pipelines came from a push-based model where we build push code and the CI pipeline does the deployment on your behalf. I think it was what was there around, but now here we are looking into GitOps, which is more focused on the pull-based model. Yeah, thanks so much for those insights. Yeah, I would say this is truly insightful, and I think this requires one to go down the road, experiment with it, because the best way you can learn is by experimenting. And yeah, and I think we appreciate those insights.
And again, if you are trying to implement, don't just focus on, okay, should I pick Argo CD? Should I pick Flux CD? Should I pick GitHub or GitLab or whichever one? Just focus on the thing you should be thinking about is the best practices, the culture, the reasoning behind why that concept came in. When you start thinking different from tools and just thinking about, okay, the reasoning behind why that tool exists. If you want to learn, for instance, you want to learn Terraform, it is not just about learning Terraform. The first question you should be asking yourself is, what was the problem Terraform was trying to solve? when you understand the problem that Terraform was trying to solve, then you understand the best practices to implement. And then you shift your focus from I am learning this to why am I learning this? Why does this matter? In this whole DevOps environment or GitOps environment, whichever one.
Yeah, actually, I would say that's a truly good emphasis. I think most times we tend to dive so much into tools, and I think for our earlier discussions, we try to drift away. Let me use the word drift, drift detection. So we try to drift away from basing on a tool because yeah, Argo or Flaxseed are so popular, but it's all about understanding the underlying fundamentals which can inform I think which tool you get to work with. But the core concepts don't really the core concepts are really the fundamental to this, right? And I think that's what really matters, right? With any tool or culture you want to embrace, right? It's understanding the underlying core principles, then you build on top of that. Yeah. So I think if you have any question, Promise is reachable on LinkedIn. And yeah, you can always reach out to her. Promise us. This is our second session with the team here, and she's always open to sharing knowledge with the team. So I encourage everyone to, reach out to her on LinkedIn. In the LinkedIn posts, we have been tagging her. In the invites, the her name has been there and links to her profile. Yeah, please feel free to reach out in case you have any question regards to DevOps, site reliability engineering. Promise is always a call away. And Promise, once again, we appreciate you honoring this invite again and coming again to share deep insights with us. And hopefully, we hope, to learn and, engage you more. And thank you for being
Hopefully.
open to our invites. You're always
Yeah,
open to our invites.
I always like to talk about the stuff because
Yeah.
I always feel like I could just go to webinars and demo tools, but it's not about the tools. It's about understanding the concept behind all the stuff. So that's why most times when it comes to me trying to build a workshop of you use this tool, you use this tool, but that might not even fit what you want because Flux CD might actually be better for you than Argo CD. It depends on your environment. And with the age of AI, just to throw this in, with the age of AI, things are gradually changing, right? We are moving away from this, or you have to write something. I mean, there's something that could generate a declarative config for you immediately right now. Now, who are the people that would survive this ecosystem right now? Are the people that are able to think systems, that are able to think, okay, I need to build an infrastructure. I need to build a system. What do I need? What are my best practices here? How do I implement this? Because you can go to Cloud AI to say, okay, tell me the best practices to use. But Cloud AI does not understand your environment. It doesn't know whether you should pick GitHub over GitLab. You alone knows what fits your team at that moment. Now, when you understand what problem you are trying to fix, you are then able to search and say, okay, what problem was Argo CD trying to solve that solves my problem right now? You are able to match it to it. So this environment right now, you have to start thinking about systems, not tools. Yeah.
Actually, I would say that's a very rich point. And yeah, I think as humans, if you look at even the copilots, they are guided by your prompting, right? So it means the core understanding of the principles and fundamentals really comes into play to guide your prompt engineering, right? Your prompts to submit either to Gemini or Copilot so that they can be able to achieve whatever you want to achieve. Yeah, but in case of anything, please reach out. Yeah, and we appreciate again. I think even there's a comment from Amara. She says, "Well done, Promise. The session was truly insightful." Yeah, we appreciate the feedback. Yeah, and Promise, the team appreciates. I think I'm speaking on behalf of the community. We always appreciate. A recording of this is going to be uploaded on YouTube. So in case you need to review, catch up, have a grasp, you can always revisit it and catch up. Yeah. Without further ado, allow me wish you a good Friday, everyone. Thanks to Promise again. We
Thank
appreciate you
you.
sparing some time on this public holiday.
Thank you for inviting me. And
Yeah.
I look forward to some other day, someday.
Yeah. Yeah, we
Right.
always ping you. I think you're just a text away, regardless of time. So
Thank you everyone for listening, and for the Christians, happy Easter. For the Muslims, celebrate with the Christian thing. Yeah.
yeah. Happy Easter, everyone, and have a
Bye.
great day.